Chapter 0. Before we begin, Maya was standing behind the counter of her family's restaurant on a Friday night when the thought hit her. They had been open for 4 years. The food was good. People drove across the city for the arepa. But every time someone called to place an order, the line was busy. Every time someone drove over to pick up food they'd never actually ordered, it was because they'd called and given up. Orders were being lost. Money was walking out the door before it ever came in. And the worst part was that nobody could point to a single dramatic failure. Nothing had exploded. Nothing had crashed. There was no villain, no outage banner, no obvious broken screen. It was just friction. Small, quiet, expensive friction. "We need a website," Maya said to no one in particular. Her cousin Tom looked up from the spreadsheet he was updating by hand. Tom had been managing the restaurant's systems, a generous word for a shared Google sheet and a whiteboard, for the past 2 years. "A website," he repeated. "And where exactly does a website live?" Maya opened her mouth, closed it. She had no idea. A question that sounds simple. Where does a website live? You've probably never thought about this. Most people haven't. You type an address into a browser, a page appears, and somewhere between those two events, magic happens. Until the day you're the one paying for the magic. But it's not magic. It's computers. Somewhere in the world, right now, there is a physical computer, a server, that is storing the files that make up that website. When you ask your browser for the page, your request travels across the internet, reaches that computer, and the computer sends the files back to you. That's it. That's a website. So the real question is, whose computer? 3 options, 1 problem. Back in the restaurant, Maya and Tom sketched out the options on the whiteboard. Option 1. Buy a computer, set it up in the restaurant, and run the website from there. In the industry, this is called running on-premises, your own building, your own machines. You'll see this term constantly. Tom wrote, electricity bill, and what happens if it breaks next to this option. Option 2. Pay a hosting company to run a small server for them. Cheap, simple. Worked for personal blogs in 2008. Probably not flexible enough for a growing business. "What if we suddenly get 1,000 orders at once?" Maya asked. Tom added, "Can't scale," to option 2. Option 3, something else. Something they'd been hearing about. Something called the cloud. Tom drew a cloud on the whiteboard. A literal cloud shape like a child's drawing. "I don't actually know what that means," he admitted. "Neither do I," said Maya. That was the beginning of everything. What the cloud actually is. Let's clear this up immediately, because the word cloud is one of the most overused and underexplained terms in technology. The cloud is not a magic place where your data floats. The cloud is someone else's computers. That's it. When you save a photo to iCloud or Google Drive, your photo is stored on a physical computer owned by Apple or Google, sitting in a building somewhere. When you use Netflix, the video you're watching is being sent from physical servers in data centers around the world. The cloud just means computers that you access over the internet, that you don't have to own or maintain yourself. And Amazon, yes, the company that delivers packages, built one of the biggest collections of these computers in the world. They call it Amazon Web Services, or AWS. Why Amazon? It's a fair question. Amazon started as a bookstore. Here's what happened. Amazon grew so fast that they needed an enormous amount of computing power to run their own systems. They built data centers. They hired engineers to manage them. They got very, very good at running computers at scale. Then someone at Amazon had an idea. What if we sold access to all this computing power to other people? In 2006, Amazon Web Services launched. Today, AWS runs a significant portion of the internet. The website you use to book flights, the app that tracks your delivery, the streaming service you watched last night, there's a good chance at least part of it runs on AWS. It's not a monopoly. Google Cloud and Microsoft Azure are serious competitors, but AWS was first. It's large, and it's what this book is about. Meet the team. Maya didn't build Nimbus alone. She called Tom first, obviously. Tom had the spreadsheets, the supplier contacts, and the stubbornness required to actually execute on an idea. Tom knew a developer, Leo, 24 years old, self-taught, the kind of person who has already built a prototype before you finished explaining the problem. He arrived at their first meeting with a laptop and a half-finished app. "I already started," he said, opening the screen. "I think I deployed it somewhere." He had. on a server he didn't fully understand, in a region he hadn't chosen intentionally, running code that would definitely break under load. They loved him immediately. Priya came later, referred by a mutual friend. Engineering degree, security focus, the kind of person who reads postmortems of famous tech failures on weekend evenings. She had one question at her first meeting. Has anyone thought about what happens if someone tries to break in? Silence. Welcome to the team, said Maya. What this book is. This is the story of Nimbus. Nimbus started as a restaurant ordering system and became something much bigger. As it grew, it ran into every problem that growing software runs into. Systems that couldn't handle the traffic, data that got lost, servers that went down at the worst possible moments, costs that grew faster than the revenue. And every time they hit a problem, they found an AWS service designed to solve exactly that kind of problem. This book teaches you AWS by following that journey. You'll learn not just what each service does, but why it exists, when to use it, and just as importantly, when not to use it. Every tool has trade-offs. Every decision has costs. That's what senior engineers understand that junior engineers are still learning. By the time you finish this book, you'll be ready to sit the AWS Solutions Architect Associate Exam, SAACO3. More than that, you'll be ready to walk into a real technical conversation and hold your own. That's the promise. A few things before we start. This book assumes you know almost nothing about cloud computing. If you've heard of AWS but never used it, you're in the right place. If you've never heard of AWS at all, you're also in the right place. This book does not assume you're a developer. Maya isn't one. Tom barely is. You don't need to write code to understand architecture. You need to understand problems and solutions. This book will sometimes be wrong on purpose. The team will make mistakes. They'll choose the wrong service. They'll skip a security step they'll regret. They'll over-provision and under-provision. That's how they'll learn, and that's how you will too. The exam tips are real. The SAACO3 is a real exam. The scenario-based questions at the end of each chapter are designed to feel like the actual exam. If you can answer them, you're on track. And one more thing. Read this book with a pencil or a notes app or a running list of, I think the answer is moments. Pause before the team decides something. Make the call yourself. Then keep reading and see whether you would have made the same trade-off. Summary. The cloud is on-demand access to computing resources over the internet. Someone else's computers that you do not have to own or maintain. The 3 hosting options. On-premises, your hardware, your costs. Shared hosting, limited does not scale. Cloud, pay-as-you-go, scales with demand. AWS launched in 2006 when Amazon opened its data center infrastructure to external customers. It remains the largest cloud provider, followed by Microsoft Azure and Google Cloud. Nimbus, the story this book follows, starts as a restaurant ordering system and grows into a production-grade cloud architecture. This book teaches not just what each AWS service does, but why it exists, when to use it, and when not to. Exam tips: SAACO3 domain, cross-domain, cloud concepts, fundamentals. The cloud on the exam means on-demand, pay-as-you-go computing over the internet. It is a delivery model, not a technology. CapEx versus OpEx. On-premises infrastructure is capital expenditure. CapEx, upfront hardware purchase. Cloud is operational expenditure. OpEx, recurring usage fees. Exam scenarios asking about eliminating upfront costs or shifting from CapEx to OpEx point toward cloud adoption. Cloud benefits: no upfront hardware, elastic scaling, pay only for what you use, no physical infrastructure management. Scenarios with unpredictable traffic or small team, no hardware expertise are strong signals for cloud. AWS is not the only cloud. Azure and GCP are real competitors, but the SAACO3 exam is AWS specific. You will not be asked to compare providers. Strengths and limitations. Strengths of this approach. Learning through a continuous narrative gives concepts context before they get names. By the time you reach IAM or RDS, you've already felt the problem they solve, because Nimbus felt it first. This makes retention higher and trade-off reasoning more natural than memorizing feature lists. Limitations to be aware of. This book covers the AWS SAACO3 Solutions Architect Associate curriculum. That's a substantial scope, but it isn't every AWS service. And production architectures always involve services and constraints specific to your industry and scale. The Nimbus story is fictional. Real startups make messier decisions for messier reasons. Use this book to build the reasoning, not to copy the architecture. Exercises. Exercise 1. Recall in your own words. What is the cloud, and why would a small business choose it over buying their own servers? Hint. Think about what Maya and Tom wrote next to option 1 on the whiteboard. Exercise 2. Exam practice scenario. A small startup is launching a food delivery application. They expect low traffic initially, but anticipate rapid growth if the product is successful. The founding team has no experience managing physical servers. They want to minimize upfront costs and avoid the operational burden of maintaining hardware. Which of the following approaches best meets their requirements? A. Purchase a dedicated server and host the application in their office. B. Use a cloud provider to host the application and pay only for what they use. C. Partner with a co-location data center to rack their own servers. D. Build the application to run entirely offline without internet infrastructure. Hint 1. Think about what the startup needs to avoid as much as what they need to have. Hint 2. The scenario specifically mentions no experience managing hardware and minimize upfront costs. Which option eliminates those concerns? Hint 3. We described this option in this chapter as paying for someone else's computers. Answer: B. Explanation. Cloud providers like AWS offer pay-as-you-go pricing with no upfront hardware costs, and they handle all physical infrastructure maintenance. This is exactly the model that makes sense for a startup with uncertain traffic and no hardware expertise, just like Nimbus. Why not they? Purchasing a dedicated server requires upfront capital, ongoing maintenance, and offers no built-in ability to scale as traffic grows. Why not C? Co-location solves the space problem, but the startup still has to buy, maintain, and manage their own servers. Why not D? A food delivery application requires internet connectivity by definition. SAACO3 domain, cross-domain, cloud concepts fundamentals. Exercise 3, architecture challenge optional. Maya wants to convince her uncle, who owns the restaurant, to let her build a cloud-based ordering system. He's skeptical. Why would we pay Amazon every month when we could just buy a computer once? How would you explain the trade-offs? What would you say are the biggest advantages of the cloud approach for a restaurant? And what's the one scenario where buying your own computer might actually make more sense? There is no single correct answer. The goal is to practice thinking about trade-offs. Post-credit scene. Late that night, after everyone else had gone home, Maya sat alone in the restaurant with her laptop. She'd found the AWS website. She'd clicked through a few pages. There were hundreds of services listed. Hundreds. She scrolled down and down and down. Then she closed the laptop. We're going to need a plan, she said to the empty room. In the next chapter, why companies stopped buying servers and started renting them, and what that changed.